The Poisson distribution is used to predict the number of events occurring within a given time interval. I'll discuss it in the next 5 minutes. There is a dam which claimed can survival flood occur once every 100 years. However, only after a decade, it's damaged by a flood pretty badly. Is this dam not past the QA, or the officials lie to the public? Don't rush to the conclusion. Let's use statistic and probability method to do some analysis. First, floods occur once every 100 years, means that over the long term, on average, the flood happens every 100 years. Will it happens once every 100 years? Could be, but not necessary. If the flood happens every year for the first 3 years in a row, and then stopped for the next 297 years, on average, it's still once every 100 years, isn't it? So, to answer the question, let's calculate the probability of the flood happens 1, 2, 3, or 4 times in 100 years. Poisson distribution can be used to address this kind of problem. It developed by French mathematician Poisson in 1830 to describe the number of times a gambler would win a rarely win game. It can be used to find the probability of a random event in a time period, or find the probability of waiting some time until the next event. This is the formula of Poisson distribution. E is Euler's number. K is the number of occurrence. Lambda is the expected value of x. In our case, floods occur once every 100 years, so the expected value of the flood happen once during 100 years is 1. Let's plug all the numbers into the formula. K equal to 1, which means flood happens once during 100 years time, is 36.8%. K equals 2, which means flood happens twice during 100 years time, is 18.4%. K equals 3, which means flood happens 3 times during 100 years time, is 6.1%. K equals 4, which means flood happens 4 times during 100 years time, is 1.5%. From the number, you can see it's quite possible the flood happens multiple times during a 100 years interval. For a large enough Poisson distribution, it will become similar to a normal distribution with certain standard deviation and mean. To help you understand it, let's see this diagram. This is during 100 years, the probability of flood times. This is during 200 years, the probability of flood times. This is during 500 years, the probability of flood times. This is during 1000 years, the probability of flood times. By the way, you can find the code used to generate these diagrams in the description. The event occurs independently of Poisson distribution. The occurrence of one event does not affect the probability that a second event will occur. For example, if it is a flood this year, will it affect next year's flood probability? It won't. Bridge connects statistics and probability. Back to the example, how likely that the dam being damaged by the flood in a decade, if it's designed to survive floods occur once every 100 years? Obviously, we don't have enough data to exempt the claim. Another extreme example, the half-life of xenon 124 is about this many years, roughly 1 trillion times the current age of the universe. So, make one observation of the half-life period of it is simply impossible. Use Poisson distribution, observe a group of xenon 124, record how many atoms diminished. If the number fit the Poisson distribution, then it follows the normal distribution. So we can use the normal distribution model to study it. It is the Poisson distribution that gives the statistic the power to make predictions. Before it, statistic can only be used to describe an event. 3 takeaways. 1. For a large enough Poisson distribution, it will become similar to a normal distribution. 2. The events occur independently of Poisson distribution. 3. Poisson distribution is the bridge that connects statistic and probability. I'm always here at your service. See you in the next one.